G'day team, welcome back to another video, and we're going to continue on our continuous random variables. Now, we're going to look at something called a probability distribution function, and this is sort of where we start integrating calculus into statistics, and it's actually really cool to see. So for a continuous random variable x on domain A to B inclusive, the probability density function is f of x such that the probability of x being between another c and d, which is inside a and b, is the integral from c to d of f of x dx. So if I integrate my function between two values, that tells me the probability of it being in between that range. Now, for f of x to be a valid probability distribution function for x on domain A to B, f of x must be greater than or equal to 0 for all a to b. So that means my whole function must be above the x-axis. We must also have that the integral from my limits of f of x dx equals 1. So it's a real easy test to do. Because it's a definite integral, you can do that on your calculator. Okay, really simple to do. We're going to do an example and show you by hand using the fundamental theorem of calculus, but you can go on and check my answers on the calculator as well. So consider the probability distribution function f of x equals cos of x. Now that is between 0 and x and pi on 2. So check that f of x is a valid probability distribution function. Should be just function. Now we know with our unit circle that between 0 and pi on 2, cos of x is positive. So that ticks that box. Now we must also check that it is valid in terms of our integral. So we need to be finding the integral from my lower limit 0 to my upper limit pi on 2 of cos of x with respect to x, and we want to show that that equals 1. Now obviously when we integrate cos of x, we get sine of x, and we want to integrate that or solve that at the limits pi on 2 to 0. So I get sine of pi on 2 minus sine of 0. Now you can use your unit circle. You should probably know sine of pi on 2 now is 1. Sine of 0 is 0, and that equals 1. Therefore, we have a valid probability distribution function. Now, because we've actually done the hard work, we found the integral, we can just plug in our values that we want to find. So the probability of x being between 0 and pi on 4, okay, that's going to be equal to the integral, but remember we don't actually have to do it, we could just solve my integral at those limits, so pi on 4 and 0. Just be careful to get the right order, biggest on the top, smallest on the bottom. So sine of pi on 4 minus sine of 0. Now sine of pi on 4 is root 2 on 2, and we know sine of 0 is 0 as before. So the probability that that occurs is root 2 on 2, or if you do it on your calculator, you get as a decimal 0.707 approximately. Okay, so that's the probability it lies in that domain. Now again, we'll just quickly do it in terms of pi on 4 and pi on 3. So sine of x, and we're solving that from pi on 3 on the top, pi on 4 on the bottom. Now sine x of pi on 3, that's the bigger angle, so that's going to give us a higher sine value, which means it's going to give me a half, root 3 on 2, sorry. So root 3 on 2 minus root 2 on 2, and we can bring that together as root 3, take root 2, all over 2. And as a decimal, I'll quickly calculate that for us. So root 3, take the square root of 2, all over 2 is 0.159 approximately. All good, beautiful. All right, find B such that f of x equals x squared over 9 is a valid probability distribution function. Now we are going to we could graph our function f of x equals x squared on 9 and solve for it on there and show that it's positive for the whole time. But let's use integration. So we're going to assume it's above the x-axis for the whole time, and we're going to utilize b as our upper limit. Now we're told it's valid, so that means from 0 to b of x squared over 9 dx has to equal 1. Okay, for it to be valid, it has to be equal to 1. So if I integrate x squared over 9, I raise the power by 1, divide by the new power, which just means I'm timesing 27 by 9, and I'm going to solve that b, 0 equals 1. Now, fundamental theorem of calculus, we put the b in, b cubed over 27. Don't actually need that bracket there. Minus 0 equals 1. Times both sides by 27, and I get b cubed equals 27. To solve the cube, we take the cube root, so b equals the cube root of 27. That means b is equal to 3. So b being 3 and our upper limit will give me my function x squared over 9 as a valid probability distribution function. Thank you for watching a bunch of different examples there. Hopefully it helps, and we'll catch you in the next video. Bye.